In this tutorial, we will find the probability of a compound event. So first, let's talk about what a compound or a simple event is. A simple event is something that happens once. For example, I reach into a bag and I pull out a red marble. I do that one time, that's a simple event, right? If there are 5 marbles in the bag, one of them is red, I've got a 1 in 5 chance. That's a simple event. Now, a compound event would be if I reached into that same bag, pulled out a marble, then put it back in the bag, and pulled out another marble, and then put that back in the bag and pulled out another marble. And I wanted to find the probability of that happening 3 times in a row of getting a red marble. These problems have a bunch of compound events. So let's look at the first one. Joe DiMaggio was a Hall of Fame baseball player. He averaged about 1 home run for every 19 times he was at bat. At that rate, what is the probability he could hit 2 home runs in a row? So there is your compound event. Not what's the probability of him hitting 1 home run. We know what that is. That's 1 out of 19. But what about hitting 2 home runs in a row? One event of hitting a home run followed by another event of him hitting another home run. We know that the probability of him hitting a home run is 1/19 in the first at bat. So what is the probability of him hitting a home run in the second at bat? It doesn't change any. We're told to calculate it based on the same rate, and that is 1/19, so 1 over 19. Now he has drawn it out twice, so we now have to multiply these by each other. That's how you calculate the probability of a compound event. You multiply the two by each other. That's going to give you 1 over 19 times 19, which is 361. So the probability of him hitting 2 home runs in a row is 1 out of 361, or letter A. Let's move on to number 3. A prize wheel at a country fair is divided into 9 equal sections. Each section on the wheel is marked with a letter. Each letter refers to a different stuffed animal prize. G stands for a giraffe, Z for a zebra, M for monkey. If the wheel stops at the letter C, the winner may choose any of these animals. What is the probability that the first 3 people in line will spin an M? Let's first calculate the probability of getting an M in one event. We see there's an M here, and there's an M here. So the probability of getting an M in one event is 2 out of 9. So every time I spin the wheel, I have 2 spaces on that wheel out of every 9 that I could get the letter M. Now, I'm not just spinning the wheel one time. So with one time, we would have a probability of 2 out of 9. I'm spinning it 3 times because the first 3 people right after the other, what's the probability that they would get the letter M? So that would be 2 ninths, 2 ninths, and then 2 ninths again. And we would multiply those by each other. And that is going to give us 2 times 2 is 4 times 2 is 8. So 8 out of 9 times 9 is 81 times 9 is 729. So we would have a probability of 8 out of 729, or letter A. There's one more thing I want to tell you. Both of these events are what are called independent events. There are independent events and dependent events. An independent event is one in which the second event or the third event is not dependent on the first. So for example, rolling a dice. If I roll a die, I roll it one time, I want to get the number 1, I've got a 1 in 6 chance. If I roll it the second time, it's still a 1 in 6 chance. Roll it the third time, it's still a 1 in 6 chance. Those events are independent of each other. But we do have what are called dependent events. And in those cases, it's like a bag full of marbles. Let's say you have 1 red marble in a bag of 10 marbles. The first time you draw a marble out of the bag, you reach in, you got a 1 in 10 chance of pulling out a red marble. But let's say you put that marble aside. Now, what's the new probability that you'll get a red marble? You reach in, it'll be 1 out of 9 because there's only 9 marbles left in the bag, and so you have to set that one aside. Next time, if you don't get a red marble, 1 out of 8 this time. And so you wind up with those events being dependent on each other. We don't need this for these problems, but it's something you will probably need for the future.